is just an extension of what we've done so far. These problems in 8.9 so far have been based on the geometric formula. And there's one more extension we can do, one more way to do these. If I give you that 1 over 1 plus x is equal to this particular series, which is basically geometric, with the first number being 1 and the value of the common ratio being negative x, and that leads to these terms. I start with 1 and multiply by negative x every time. If I give you that as a basis, you can use that to solve other problems. For instance, what if I ask you for this one? Remember, our overall goal here is to get an infinite series, a power series, that represents these functions um, and is equivalent to these functions. We want to express them with an infinite series. This particular one has got this bottom squared, and it doesn't really fit. I can't really force it into being into the geometric formula like we did at the beginning of this section. So certain ones, if you're given this info at the top, then you can use that to figure out a new one that doesn't necessarily work. In the first part of this section, we made it be centered at the right place, and then we made the bottom be 1 minus whatever, and we forced it into looking geometric, and then we just chose A1 and R based on that. This one doesn't work exactly that way because of this x plus 1 being squared. It's not going to exactly fit. However, and this clue is given in your book on this particular problem, what I'm giving you is the derivative of 1 over 1 plus x. Okay, take the derivative, you have something to the negative 1, that becomes negative, that's something to the negative 2. And you can convince yourself that the thing I gave you to start is the derivative of the given info at the top. So if I want to find an infinite series for this function that's given in the example, I just need to take the derivative of the one I have at the top. All right, if I start with my given info, I can do this in sigma version, or I can do this in term by term. I'm just going to rewrite what I have at the top. Well, I don't know how to force this one into looking geometric, but I do know that the one I'm looking for, negative 1 over x plus 1 quantity squared, is the derivative of the one that I do know. So I can just take the derivative of this term by term, or I can take the derivative of the sigma. All right, the derivative of this sigma, all right, it's still going to alternate. So I'm still going to have a negative 1 to the nth power. And then I'm just going to apply the power rule to the rest. I had x to the n. That turns into nx to the n minus 1. Okay, so a term at a time, that would be negative 1 plus 2x minus 3x squared plus 4x cubed minus 5x to the fourth, and so on. If I just take my terms and take the derivative of each one. And if you go by the sigma notation, I start with 0, that term's gone, so I really don't need to start at 0 anymore. If you start at 1, you plug in 1, you get negative 1x to the 0, which is negative 1. Then I get positive 2x to the first, minus 3x squared, and so on. So the infinite power series for the function I asked you for is right here. Here it is term by term. Here it is in sigma. All right, and the connection was it was the derivative of the given one. So this is just one more way I can give you a function and ask you to find an infinite series representation of that same function. One more example, and this is one that here's what they tell you. They tell you to find a series for x over x squared minus 1. And their hint is that this is equal to 1 over 2 times the quantity 1 plus x minus 1 over the quantity 2 times 1 minus x And that would have been found through partial fraction decomposition. But they found that and gave it to you so that then you could use the given from above and just slightly adjust it by, throwing the 2's down there in the bottom and making one of the r's negative and one of them positive and using that clue. If I just gave you this, I don't need to give you any clues, so I'm going to reject their clue. Anytime that the bottom has a 1 on it, and these two terms down here, we can kind of treat it like we did in the first section, the first part of this section. We can force it into looking like geometric. So if I want to make this look geometric, I'm going to first put the 1 over here. Then I'm going to multiply top and bottom by negative 1 and get, negative x over 1 minus x squared. So this is exactly the same as what I just asked you for. And if you can make it look like a1 over 1 minus r, then you can just pick the a1 and the r out. Our a1 is negative x, and our r value is x squared. All right, because we forced it into looking geometric. All right, but this other one had that quantity squared right here. That really messed with our ability to make it look geometric. But this one, it's giving us, we got a 1 down there already, and there's some other term. So I'm not going to do it the way they asked. If I give you this on a test, forget their clue, forget the partial fractions, and just make it look geometric. All right, so you got to kind of, be clever on these, and if you can make it geometric, make it that way. So anyway, if this is a geometric, they're always a1 times r to the n. So that's going to be negative x times x squared to the n. All right, well, all of these terms are negative. All right, this is not an alternating because the negative doesn't get raised to a power. They're all negative. So I'm just going to take that negative out front. And then once the negative comes out, I've got x to the 2n and an additional x. So that's x to the 2n plus 1. Okay, and if you had used their hint and put together the two separate series and gone through all of that stuff, you would have come out with this exact same answer. The radius of convergence, by the way, we need our r value to be between minus 1 and 1. So, in that case, the radius of convergence, we just square root. We still get x is between minus 1 and 1. All right. So there will be some in your book that they try to get you to use a different hint on. I personally would, anytime you can make it look like a1 over 1 minus r, that's going to be a much better path. So there's not too many more in the section that are acting like this. This will wrap up this chapter, and then we'll be getting ready to prepare for the test. All right, so I'll see you in class. Young out.